Find the area of the green triangle. Line construction, trigonometric identities, tangent-secant theorem, Pythagoras' theorem, area of a triangle. Basic arithmetic and algebraic processes are used to solve this question. Solution to question 1. Label points B, C, D, and E. Construct line B equals 8. It is because opposite side length of a rectangle are equal. Line C equals 2 times R. It is the diameter of the semicircle. From triangle BCE. Using Pythagoras' theorem. The square of line BC equals the square of line CE minus the square of line BE, which equals to 4 times the square of R minus 64. Take the square root of the equation. It implies that line BC equals the square root of 4 times the square of R minus 64. Also, label line X and line BD equals Y. Measure length 4, as shown on the figure. This is half the length of the square. Also, line OB equals to R, which is the radius of the semicircle. It follows that X equals 8 minus line BC, which equals to 8 minus the square root of 4 times the square of R minus 64. By secant tangent theorem, the product of X and the sum of X and length of line BC equals the square of 4. After substitution of values and simplification, it implies that the product of 8 minus the square root of 4 times the square of R minus 64 and 8 equals 16. Divide the equation by 8. It signify that 8 minus the square root of 4 times the square of R minus 64 equals 16 divided by 8, which equals to 2. Combine like term. We have that the square root of 4 times the square of R minus 64 equals 8 minus 2, which equals to 6. Take the square root of the equation. This implies that the square of the square root of 4 times the square of R minus 64 equals the square of 6, which equals to 36. It follows that 4 times the square of R equals 36 plus 64, which equals to 100. Divide the equation by 4. We have that square of R equals 100 divided by 4, which equals to 25. Take the square root of the equation. Hence, R equals the square root of 25, which equals to 5. This implies that line BC equals the square root of 4 times the square of R minus 64, which equals to 6, after simplification of substituted values. Label point G. Let angle ECG be equals to theta. Hence, angle BC equals 90 degrees minus theta. From triangle CEG, by trigonometric identity, line CG divided by line C equals cosine theta, which equals to 4 divided by 5. We call it equation 1. Consider triangle CBD. Line BD divided by line BC equals sine 90 degrees minus theta, which equals cosine theta. Substitute values and equation 1. We have that y divided by 6 equals 4 divided by 5. Cross multiply so that y equals 4 times 6, all divided by 5, which equals 24 divided by 5. Using Pythagoras' theorem in triangle BOD. The square of line OD equals the square of r minus the square of y, which equals the square of 5 minus the square of 24 divided by 5, which equals to 49 divided by 25. Take the square root of the equation. It implies that line OD equals the square root of 49 divided by 25, which equals to 7 divided by 5. Hence, area of triangle BOD equals half the product of length of line OD and y, which equals to half the product of 7 divided by 5 and 24 divided by 5. The result is equals to 84 divided by 25 in square units. That is equals to green area. Therefore, the area of the green region equals to 84 divided by 25 in square units.